Okay, everybody. They tell me that we want to get started about 15 minutes early for this last thing, so I'm going to start now. My name is Mark. I'm a developer on the Azure Developer Experience team at Microsoft. I'm going to talk to you today about the cross-platform Azure PowerShell modules. And this is going to be a bit of a hybrid. So I'm going to highlight a lot of the things that we've done in the Azure modules over the last year. I'm going to talk about kind of what it means to have cross-platform modules. There have been a few talks today about that. I'm going to go a little bit into the AZ module implementation. And then I'm going to talk just a little bit at the end about the generator, which you just saw in the last session. And I'll try to leave some time for Q&A. I'm really glad that we got the air conditioning running. That's kind of nice. Just to get started with, how many people have used Azure PowerShell before? Okay. How many people use it like once a week or more? Okay. So we have some regular usage. That's pretty nice. So for those of you who don't use Azure PowerShell, so Azure PowerShell is a set of client commandlets for Azure services. And this is based on the public REST APIs for Azure. So all of the tools that you use for Azure, that's the Azure Portal, Azure CLI, Azure PowerShell, all of the SDKs are based on these public REST APIs. This will be important when we start talking about Commandlet implementation, because we have formal specs of these REST APIs called Open API specs or Swagger specs that go into actually how the actual implementation occurs. So we'll talk about that. And what I mean by creating and managing Azure artifacts are things like VM, storage, telemetry. Basically, we allow you to create, remove, update, track everything that you have going in Azure. So we represent about 70 or so services. It's more than 70, more than 50 modules. We have an architecture so that such that if you so that we have basically one module per service. It's not quite one-to-one. The idea is if you have a script that's only using a few Azure services, you can download a few modules and take up less space. If you want the whole thing, we have a rollup module that will give you everything. We ship in Cloud Shell. In fact, we'll be shipping in Cloud Shell on Tuesday again. And we're on the PowerShell gallery. They are the PowerShell commandlets. Even though when you look at them, they show up as script commandlets, they're actually binary commandlets. Does everybody know what a binary commandlet is versus a script commandlet? Okay, so I'll talk about that just a little bit. And they're open source. So like all of the Azure tooling, and like PowerShell, which PowerShell going open source is like the greatest thing since sliced bread, I think. But we're open source on GitHub. And first, I think I'm going to show you a little bit about what's in our repository for those of you who actually use us. So this is our repository. It's in the Azure organization. It's just Azure PowerShell. And there's lots of things here that might interest you. So all of the source code that goes into Azure PowerShell is here. All the tests of Azure PowerShell is here. All of the help files for Azure PowerShell is here. Quite a bit of documentation. In addition, you can file issues here for Azure PowerShell, and there's an awful lot of community involvement with issues, lots of back and forth. And you can also see the upcoming 5 or 6 milestones that we have going on, and at least in terms of what the core team is doing, kind of what's going to happen in those milestones. So that can be kind of useful. We have records of all of the releases here under the release. So lots of good stuff. And under the source folder is kind of where all of the Commandlet implementations are. So this is the implementation for Connect Azure RM account. So this is the main login commandlet. And the big thing about a binary commandlet is represented as a .NET class. And it's somewhat similar to script commandlets. So first of all, the commandlet properties, like whether it supports should process, its name, all of that kind of stuff go in a commandlet attribute. You can have alias attributes. The output type attributes help PowerShell deal with deal with the outputs. But just like a script commandlet, you use attributes to specify the properties of your parameters, like you see down here. And just like script commandlets, we have begin and process. So that's kind of what a binary commandlet is about. I'm sorry? Yeah, this is a binary commandlet. If you actually do get module, it will show up as a script commandlet because there is a PSM1 file that actually does some environment setup before the commandlet actually gets loaded. So the commandlets themselves are binary commandlets, but it shows up as script because there is a PSM1. Yes. So what I kind of wanted to show you, this is one of the things that's kind of cool about having this, and kind of giving it away here. So this is docs.microsoft.com, which is where you get all the documentation on Microsoft stuff. Docs.microsoft.com/PowerShell/Azure gives you all of the documentation on Azure PowerShell. And what we have here is exactly the same thing that ships with the help with the Azure module. So one of the cool things about having a repository here is that I can actually, on docs.microsoft.com, I can just hit this edit button, and it takes me directly to where this commandlet is inside our repository. And if I see something where I want to correct an example, or I want to provide a little bit more information, or I want to add my own example, let's see, like here, let's say I just want to say this is for an Azure virtual machine. Yeah, you never want to commit directly. Actually, you guys probably can't commit directly, but basically I can just say update docs, and this will actually create a pull request into our repo. And the next time we ship, this will actually go out with our docs and get updated on docs.microsoft.com. So it's kind of cool, and we really appreciate it when we get that kind of participation from people. So the last thing here is, yeah. The help changes, I didn't hear the last part. So the help file, so we actually use PlatEPS to generate the markdown files for help. So they're represented as markdown files in the repo, as you saw. So most of what's in that markdown file is actually generated from the C# code. And when things get updated, it actually does a pretty good job of merging what's going on with the C# file with these changes. So basically, yeah, whenever you regenerate, if you've made changes like this, they still show up. So the last thing is that many of you may know that we recently shipped the AZ module. This is what's currently shipping in Cloud Shell. And this is our cross-platform module for Azure PowerShell. Cross-platform in that we have one set of modules. They contain one set of DLLs, and they can run on PowerShell 5.1, PowerShell Core 6, PowerShell Core 6.1, and so on. So this is the announcement page for this. Later on in the talk, I'll show you where this thing is. This has the roadmap. This is where additional information about the AZ module and how the transition is going will be. So this is an important thing to know, and we'll have that up there later. So enough about the repo for now. So as I was saying, we're cross-platform and run on 5.1 and Core. And we use a net standard for cross-platform execution. How many people know kind of the difference between net standard and net core? So a few. Some people do. I'll talk about it briefly. So basically, you can think of net standard as an API specification. So think of it as a collection of the public interface set of APIs. Net standards has versions that go from 1.0 to 2.0, but they're not actually different versions of the APIs. Each successive version is a superset of the previous one. So 1.1 contains the APIs in 1.0, 1.2 contains 1.1 and 1.0, and so on. And basically, it's just a specification, and there are many implementations of it. Two of the most common ones are .NET Core and .NET Framework. And just like lots of things at Microsoft, which is great to see, it's open source, so you can go to the .NET organization on GitHub and go to their standard repo and see everything about .NET Standard that you need to know. .NET Core is an implementation of .NET APIs, and it implements the .NET Standard specification. So different versions of .NET Core implement different versions of .NET Standard, and it's also open source. So what this looks like is something like this. So for .NET Standards, .NET Standard started with 1 up to 2.0. .NET Core 1.0 implemented everything up to .NET Standard 1.6. And .NET Core 2.0 and .NET Core 2.1 implement .NET Standard 2.0. .NET Framework, since 4.5, has implemented some of .NET Standard. And starting in 4.6.1, you can actually run .NET Standard 2.0 apps in the full .NET Framework. Now, that's a little bit of a fib. It's actually true that you can run the code in .NET 4.6.1, but you require special configuration and additional DLLs in order to do that. The first version of the .NET Framework that really supports .NET Standard 2.0 out of the box is 4.7.2. So if you install 4.7.2 on your machine, you can run a .NET Standard 2.0. A .NET Standard 2.0 DLL. And just to get the point about implementation versus specification, not just .NET Core and .NET Framework, also Mono and Xamarin implement .NET Standard. So just to talk about how the commandlets can work on two different platforms. So we basically have the commandlet code, like the commandlet code that you saw. And that commandlet code is just using the APIs from that .NET Standard implementation. And they're also using the system.management.automation APIs the PowerShell team provides from their new PowerShell standard library, which is also built on top of .NET Standard. So when we're running on top of .NET 4.5, we get the PowerShell 5.1 runtime and .NET 4.5 implementing those actual libraries. And to the commandlets, it's transparent. And then when we're on Core, we get the PowerShell Core runtime, and we get .NET Core implementing those APIs, and again, transparent to the commandlets. As I was talking about a little bit, you saw that commandlets are represented of those C# classes that have attributes, and PowerShell loads them via reflection. So we deliver them as dynamic link libraries. PowerShell reflects over those libraries and finds all of the classes that have those commandlet attributes and decides based on that what are the commandlets to export. Just to go over this with 5.1, if you have .NET Framework 4.7.2, so for PowerShell 5.1, if you have .NET Framework 4.7.2, you're supporting .NET Standard 2.0, and also in 6.0, which is .NET Core 2.0, and 6.1, which uses .NET Core 2.1. So all of these will support the new AZ module. So now I'm going to actually show you the AZ module. How many people have used AZ versus Azure RM? How many people used Cloud Shell? OK, so it's kind of like the same group. Yeah, if you've used Cloud Shell, you've actually used AZ, and you may not have known that you were using AZ. So I'm going to talk about some of the things that we've done in AZ over the last. I can try. Better? OK. So one of the things that we've done is given you a little bit more control over the way that credentials are managed. So by default, when I install AZ, whenever I log in, my credentials are actually remembered in the next session that I open, and actually in all the sessions that I open. So for example, right now, I can run the get context commandlet and see that my current context is already set up. So I'm using this subscription called Node. I'm logged in as me. and I can actually just go ahead and use this without doing any kind of login.
Can we have two processes using different credentials on the same logs?
Yes. So a couple of the things that you can see here. One is, I'm actually going to talk about that exactly, so that is an excellent segue. So one thing that I can do is actually list all the available contacts. So whenever I log in, I'm actually given access to all of the subscriptions that I have access to. If I have access to thousands of them, not all of those. But basically, I have all of these different contexts that I can switch between. And in this session, I can do like select context. And let's say I wanted to use a different subscription. Let's say I wanted to use that subscription. I would just use select context, and then suddenly I'm using that subscription. You can also rename these. So these are the default names that we give them because they're the subscription name, which is what most people use. They're also your credentials that you're currently used to log in. You could be logged in with multiple things. But if, for example, going to your question, if I were to select a context like, say, this context, I can actually say, I only want this to be for the current process. So, for example, if I wanted to use this particular context just here, and when I open up other sessions, I want to be back to the other context, I can do this way. There's actually a few other ways that I can do this as well. So this is default behavior. I basically remember my context from one session to the other. Now, I'm going to open up PowerShell Core. And just to show you, you can see that we're actually running AZ here. And now that I think about it, see, we're running the same versions of 0.4.0 AZ over here. But another thing that I can do is if I'm on a machine where multiple people are using the same user account, or for some other reason I just don't want the context to be saved, like I'm running lots of automation, I want to log in each time, then we have some commandlets that enable you to change that behavior. So we have disable AZ context autosave, and I can, for example, just turn off autosave for this particular process. So I can say, starting up this process, I want to be disconnected from the saved context. And then I can actually clear the context, and I'm starting fresh. So if I do get AZ context here, then you can see that I don't have any context. However, if I start up a new session, yes. Thank you. So you have control over that. So by default, so just to finish the thought here. So when I open up, because I've just turned off context autosave for that process, it means that if I open up something else, it's still connected to the context. Now, if I wanted to disable it for an entire machine, I would just say current user. Anytime that I'm logged in as that user, anytime I open any session, I'm going to have to log in. So if you're if you're running a lot of automation on a machine, then this is a good way to go. Or like I said, if you're in a shared machine environment, that's a good way to go. So you have control over this stuff. And not only that, you can actually pass individual contexts into Commandlets. So you have lots of control over exactly how the credentials are managed. So what I want to do here is show you a couple of other features. And something that's a little different about AZ right now. So by default, we're using device login now instead of the browser pop, and this is because of using net standard and not being on .NET framework exclusively. So what I need to do is grab this code here. And I already have a device login that I did before. And so I can pop the code in here. And because I've already logged in, I can select a previous login, or I'd get the regular things that I would get through the interactive user login experience. Right now it's logging in as me. And if I go back, correct. So the good thing about device auth is that in cases like this where I'm remoting into another machine, I don't have to actually be able to pop a browser in that other machine, which would not work the current way that PowerShell works. I can open a browser on my local machine and authenticate that login. However, we're looking at later, we're looking at some options that we have for allowing you to not have to open up that UI yourself and not have to paste this in. But still be able to opt into the device login because, as Jeffrey was saying, device login is really useful for lots of scenarios. I don't have a firm date for when that's going out, but we're trying really hard to get that up for 1.0. So we'd like it to be just as convenient as it can be for people, but still have that new functionality. So another thing that we spent a lot of effort on the last year is creating some task-based commandlets. So the way that things work in Azure, things like virtual machines tend to be very, very complex objects. So they have a configuration for the OS. They have a configuration for the network. I have to create a network. I have to create a network security group if I actually want to be able to communicate with it. So there's all kinds of things that I have to be able to create. And so the script for doing this ends up being very, very large. So what we did is went through the scenarios and found ways that we could figure out what people wanted based on just a small set of parameters. So most of the time, people want to be able to communicate with their VMs. So they need to have ports open for doing that. And most of the time, they want to be able to create virtual networks and all that kind of thing. So we have this command new AZVM. And let's see, I'm just going to call this my SEVM. And another thing that's kind of cool is that we've provided a lot of tab completers for things for things here. So I can tab through all the locations. And these are just the locations where I can actually create VMs, not all the locations everywhere. And let's see, we like Windows, so let's do a Windows image. And I'm going to have to set up an administrative credential for this thing. So let's do that. And there we go. We can go ahead and create this. And here I have to set up my admin user. And there we go. So we'll go ahead and we're creating the VM. Now, meanwhile, in my other window, I'm going to go ahead and create a VM as well, but I'm going to use another one of our features. So just quickly, we'll go through and create it in the same place. And 6-image, and we'll choose Windows again. But this time, we'll actually do this as a job. So instead of having to wait for the VM to be created and having my session taken up, I can actually do this with asjob, and it will return. But I forgot. And now, OK, there it is. Just took it a little while. So I forgot to actually put in a required parameter. So it's going to prompt me for that before it goes on its merry way. And then it creates a job, and I can just query the job, wait for the job if I want to when I need to get to the VM, but I can go ahead and issue other commandlets as I'm going along. So lots of things that we've added over the last year. And as you saw there, I was able to do that both in the PowerShell core window and the PowerShell window, PowerShell 5.1 window using the same credentials, or sorry, using the same module. So as I was just alluding to, one net standard build for all platforms. And One of the things about the implementation, so you saw the Commandlet implementation. One of the things is that in the Commandlet implementation, the communication that we do with Azure is all done through a management client in .NET. And this is actually generated, for those of you who went to the last session, by Autorest, and comes from the actual .NET SDK that's generated from the REST API for that service. So this kind of works like this. When the compute service first came out, we'll say it had an API that's at version 1. And so we create a REST specification for that API, so a formal document describing the API. And from that, we use the Autorest generator to generate management libraries, including the .NET management library. And then we write a Commandlet code on top of that management library. Now, as time goes on, Compute adds some new features, and they have another version of their API, which exists side by side with the previous one. So there's a new version of the REST spec. We again generate a management library, and we can write a commandlet on top of that. And basically, Azure Resource Manager, as we go through commandlets, as we execute commandlets, it knows based on the management library that it has to route it for this one to Compute API v1, and for this one that it has to route it to Compute API v2. So there are some problems with this. So obviously, writing custom commandlets is expensive, especially for custom commandlets that are very close to the API. So one of the things that we're starting to do right now is using the Open API spec, the Swagger spec that we use to make those management clients to actually determine the Commandlet API. And we figured that we can do this for somewhere around 60% of the commandlets. There are lots of commandlets like restarting VMs, removing things, all of the gets that are very, very formulaic, and you can tell what exactly they should look like just from the REST API. There are some other commandlets like creation commandlets, lots of update commandlets where human interaction is actually required to figure out what the things can look like. You need to actually go through the tasks that people want to do to decide how to have a good commandlet interface. So the idea is that we'll have the developers focus on ease of use for that 40% of commandlets, and we'll have the 60% of commandlets generated using this generator. So some of the things that we get out of the generator or commandlets are able to be loaded and unloaded, where strictly binary commandlets won't be able to be because we have binary implementation of the commandlets, but actually a definition of the commandlets themselves in script. So while you can't unload the DLL, you can actually unload those script commandlets when you unload the module. We'll still have strongly typed outputs and strongly typed parameters, so you still have that same experience. But another big thing that we'll get is for all the 60% of commandlets, we will get all these capabilities like asjob and completers and conformance with all of the PowerShell, with all of the PowerShell guidelines, just by design, by default. And like I said, instead of focusing on that, developers will be able to focus on actually making the user experience better for that 40% of complex scenarios. So now I'm going to show you a demonstration of a version of the API generator. So let's go take a look at this. So I've written a module that actually does a few of the things for you. All right, and generate.ps1. So what this is going to do is actually call Autorest to generate the commandlets, and then also call the extra scripts to generate the commandlet interface. So you can see it's calling Autorest. And when it's calling Autorest, you can see these parameters -Azure and -PowerShell. So -PowerShell says, Autorest has lots of generators. So PowerShell says, I want you to generate this REST API spec as PowerShell. And -Azure says, not only is it PowerShell, but it's PowerShell that's going to be used against Azure Resource Manager, which means that it's got certain kinds of, which means that we know how to authenticate it and we know how some of the commands fit together. The idea here is that if you don't have -- Azure there, this would just be a commandlet generation for any REST API. So the idea over time is that this will be a way for people to generate commandlets for any kind of REST API, for communicating with any kind of service, as long as we can get an open API spec of that service. And so we generate it, and we can actually just go import the module here. And I have to caution you a little bit. This is a version from a couple of months ago, so it's got a little bit of extra. Scripting and a little bit of extra tracing in it. So this isn't what commandlets would look like if you ran with the latest version today, but this gives you a feel for kind of what the things are like. So, there we generated the commandlets, and if we look at, we loaded the commandlet. So we have container registry management, which is the commandlet that we were just running, and we have a couple of different commands that we can see here. So one is get operations, which returns all of the different operations that can be performed on a container registry through ARM. So, and this is what I'm talking about, like the extra tracing that you see. But part of the extra tracing is actually the REST API calls as they happen, which we normally write to the debug stream. And in the fullness of time, they'll be written there as well. But you can see, if I format this as a list, you can actually see all the operations being returned for the things I can do with container registry. Similarly, I can use that get registry commandlet. And basically, you can see that I have a registry, and here are the properties that are returned from that registry. And it's using the same authentication that I have for AZ right now. It's using my current context that I'm logged in with. So that's kind of the generator. And I kind of want to show you two things. One is what these REST API specs look like a little bit, so you can see why they're actually a pretty good definition for commandlets that are close to the surface of what those commandlets should look like. And then I want to show you a little bit about, just shortly, a little bit about the code. Is that better? OK. So this is an open API spec. This is one of those specifications of what a REST API looks like. So you also hear these called Swagger specs, because that was the original name of this standard. So it starts out with some metadata, but then it's got a structure where it goes through all of the resources that you can make management calls against, that you can make REST calls against. So you can see it's got these paths, and then for each one, so the path defines the resource that you're actually affecting, and then underneath that you have all of the HTTP operations you can perform over that. So in this case, we have a post, and then inside that it describes the parameters. So here we have the parameters in the URI, or subscription ID and resource group name. So all these parameters are defined here, and then the actual payload that goes in the request is also defined, and then the possible responses that can come back from the server. So that's a large part of the document. Then at the bottom is all of the models. So the models for what the resources look like, the models for what goes in the payloads of the requests and the payloads of the responses. And these things end up being a really good representation of the API for a lot of these kinds of operations. So now just briefly, I want to show you kind of the structure of the code before we end. So let's see. So inside generate, so this is code that we generated just a minute ago. So we got a couple of different parts here. So one is the API, and the API is actually defining the requests and responses that the commandlet is going to make. So first of all of those models that were in the REST API spec that define that define the payloads of the requests and responses. These are represented here in the models. And then all of the calls that you can actually make using those models are defined in the C# code that gets generated. Then under Commandlets, we actually have the generated Commandlets. And the way that this is working is that there's basically a C# file for all of the parameter sets that you'd have in a commandlet. And then there is some script that actually bring those together into a single commandlet with a bunch of parameter sets. So the thought is that we can have these parameter sets, people can add new ones, and people can put them together to make custom commandlets based on these generated commandlets. We expect to see the generator is going to be something we're focused on for the next 6 to 8 months. So you should actually start to see modules that are generated with the generator before the end of the year, and then quite a few of them by the middle of next year. So this should be a big area of focus. And now, for more information on all this stuff, we have our GitHub repo. This is the announcement page for Azure AZPS, so aka.ms/AZPS announce. And that's all I have. Are there any questions? Yes? So there's a couple different things. So one is that to start with, we're going to be, there are new services in Azure coming online all the time, every month, new services. So the idea is to try to make sure that those new services are compliant and have great functionality and good commandlets from the beginning. So where this is going to start this year is in new services coming online with these commandlets. So there'll be no breaking changes from that. Now for the second part, it depends. There's one of the things that I didn't show too much. When I was doing the auto rest, I'm actually pointing at this markdown file. And this markdown file is a configuration for auto rest generation. And so by default, it's just pointing at the spec that I want to use. But you can also specify ways in which you want to transform the interface that gets generated for particular languages. And so when we're talking about converting existing commandlets, in some cases where we're happy with the commandlets as they are right now, we're going to actually want to make sure that we configure so that we can continue to produce that API. But there are some cases where we have commandlets that we're not particularly happy with and we want to break. So we have a rigorous breaking change process. We tell people long in advance before things break, but for some things I expect that we will actually, when we generate, we'll actually end up with a breaking API surface, and we'll have to manage how we push that out to customers so that the scripts aren't broken. Well, especially for new commandlets, yes. Any other questions?
So Mark, can you talk about, so you have Swagger, you generate commandlets. What if the commandlets that are generated are not the right, doesn't follow the practice? Do you go and talk to the teams to make them change their API, or do the size of the commandlet, or how is that?
So hopefully this gets, so there's a whole, I don't want to get too much into the process of how Azure ships APIs. But generally, we have reviews with all of these people, and we make sure that their commandlets are going to end up looking the way that we want them to look before they ship. But one thing here that's important about that, as people who saw the previous talk, one of the things that was an emphasis there is that all swaggers are not equal. There's a big difference in terms of having good swagger versus a not good swagger, and there's an awful lot of investment on our team in making sure that the swaggers are good swaggers, and so we get to leverage that in the PowerShell commandlets. Yes. So what I was trying to show there is that this is designed such that we can take those generated parts and actually put them together with script. So we can define. So if we have a set of parameter sets we want to use from that, we can define our own parameter sets as well, and then put those together into a single commandlet. Yeah. So for some commandlets, the generated commandlets will be what we ship. For other commandlets, we will be adding to the generated commandlets, and for a few commandlets, it will be just totally custom. All right. Thanks, everybody. Thanks for sticking around.